Students, we have seen how to represent knowledge using predicate calculus. We, we have seen the advantages of FOPL and elementary components of FOPL. We have seen these examples, some simple examples. We have learned how to connect WFFs using connectives like AND connector, OR connector, and negation symbol. I have given you an idea about universal quantifier and existential quantifier. Universal quantifier is used when a statement is true for all the entities in a particular domain. Existential quantifier is used when a particular statement is true for at least one entity in that domain. We have seen some examples for use of universal quantifier and existential quantifier. We will see more examples in this video. Here you are given a set of English statements. You have to convert that into WFF. In the next slide, I have converted some of these statements into a better representation form so that you can easily convert that into WFF. Here, statement number 3, 5, 6, 7 and 9 are not easy to represent and they cannot be represented directly. So I have converted them into a better form and you can easily convert that into WFF. Please go through all the examples and try to convert some English statements given as tutorial questions at the end. Try to understand the given examples so that you can represent statements on your own. All of you may be getting different answers when you try to write on your own. It is okay. The only thing that you have to ensure is the thing that you have written is usable. So please go through the examples given here. First two statements are direct. Marcus was a man. Marcus was a Pompeian. That you can represent very easily. All Pompeians were Romans. All Pompeians were Romans. That statement is a general statement that talks about all Pompeians. So you can convert that into this form. If X is a Pompeian, then X is a Roman. X is a Pompeian can be represented easily. X is a Roman can also be represented easily. Now connect these statements using implication symbol, and because all is used in the statement, you have to show the use of universal quantifier. Then fifth statement, fourth one is direct. Fifth one, all Romans were either loyal to Caesar or hated him. You can rewrite this statement as, if X is a Roman, then X is either loyal to Caesar or X hates Caesar. X is a Roman can be represented easily. X is loyal to Caesar can be represented. X hates Caesar also can be represented. Because all is used, quantifier is expected. Try to use connectives appropriately. That is implication and or are the connectives used here. Everyone is loyal to Caesar. This can be written as, for every x there is some y so that x is loyal to y. For every person x, there is some person y so that x is loyal to y. Because for every is used, universal quantifier is expected. There exists some y means only for some y or for some people. the statement is correct. So, existential quantifier is required. People only try to assassinate rulers to whom they are not loyal to. That statement can be rewritten as: if X is a person, Y is a ruler, and X tried to assassinate Y, then we can conclude that X is not loyal to Y. Marcus tried to assassinate Caesar. That can be represented easily and directly. All men are people. If X is a man, then X is a person. In that way, you can rewrite the statement so that you can easily convert that into WFF. WFF for all the given statements are given here. Here what I have done is, first I have converted the given statements into a different form. Then I have written its WFF. Please go through all the given examples, and try to understand. If you have any doubts, I shall clear it in regular class. Here some more statements are given and their representation is also given. I will give you an idea about this. Marcus was a man can be represented in WFF as man of Marcus. Marcus was a Pompeian can be represented as Pompeian of Marcus. Marcus was born in 40 AD can be represented as born Marcus, 40. Even if you avoid AD, it is not a problem. All men are mortal can be rewritten as: if X is a man, then X is mortal. And based on that, we can write: for every X, man of X implies mortal X. If X is a man, then X is mortal. Next statement is: all Pompeians died when volcano erupted in 79 AD. Here, actually this is a complicated statement. It is not very easy to represent. So here what is done is, volcano erupted in 79 AD is represented first, and that incident is connected with the death of all Pompeians. So you can write in this way: erupted volcano, 79. That statement says volcano erupted in 79. We are avoiding that representation AD. And for every X, if X is a Pompeian, then we can conclude that X died in 79 AD. So here what we are doing is volcano eruption and death of Pompeians. These two incidences are connected to convey the meaning that all Pompeians died when the volcano erupted in 79 AD. This is one way of representing the above statement. No mortal. Next statement. No mortal lives longer than 150 years. That is also a very difficult statement to represent. I will give you an idea about how that is represented. Here, X represents a person, T1 and T2 represents two different times. We can conclude that for every X, for every T1, for every T2, if X is mortal and X was born in time T1 and T2 minus T1 is greater than 150, then we can conclude that X is dead at time T2. Here GT stands for greater than. GT stands for greater than, LT stands for less than. These are called computable functions. So this is how we are representing the statement. No mortal lives longer than 150 years. It is now 2010 AD. Can be represented as now equal to 2010. Next statement is alive means not dead. For every x, for every t. Here x represents a person, t represents a time. If x is alive at time t, that implies x is not dead at time t. And if x is not dead at time t, that implies x is alive at time t. So alive means not dead. That concept is represented using two WFFs connected by AND connector. If someone dies, then he is dead at all later times. That is represented using the following WFF. For every x, for every time t1, for every time t2, if x is died at time t1 and if time t2 is greater than time t1, then we can conclude that x is dead at time t2. So these are some ways of representing English statements in WFF. So what you have to do is try to understand these examples, and when you get some statements, try to represent them in WFF and try to convey the maximum amount of information. The only thing that you have to keep in mind is whenever you are representing an English statement, that should be usable. That's all. Some statements are given here. You have to convert that into WFF. You can try this as tutorial questions. For these questions, I have given a sample explanation in the next slide. And for the last type of questions, you have to write on your own. We shall discuss answers later. Now see the questions. Vishnu likes all kinds of fruits. Narayanan likes seeing English movies. Ravi only likes easy courses. Mani is a good student. All good students have high grades. All good students with high grades are bright. I have written some statements. I have rewritten some statements. If X is a kind of fruit, then Vishnu likes X. Our first statement was Vishnu likes all kinds of fruits. That can be rewritten in this way. That is a general statement about Vishnu. So I have rewritten in the form of if then else type so that I can easily represent it using a universal quantifier. If X is a kind of fruit, then I can conclude that Vishnu likes X. Narayanan likes seeing English movies. If you want, you can represent it in a general way or in a specific way. Ravi only likes easy courses. I'm converting that statement in this form. If X is an easy course, then Ravi likes X. Or I can say, if X is a course and X is easy, then Ravi likes X. Both representations are correct. Mani is a good student. That is a direct statement. All good students have high grades. That can be rewritten as if X is a good student, then X has high grades. All good students with high grades are bright. If X is a good student and X has high grades, then X is bright. After converting the given statements into if then else form, you may find it easy to write. So try these examples and try to write WFF in your own way. These are the other tutorial questions which you can try on your own. Karate fighters are very strong. Money is a karate fighter. Money broke some body part of every other karate fighter. Money broke the leg of the karate fighter who broke the jaw of Raja. Boxers are not as strong as karate fighters. When compared to other example, this is a little bit tough, not so tough. You try it on your own. Try to convey the meaning. Some statements are specific, some are general. Try to identify that and use quantifiers appropriately. Whatever be the solution that you are getting, keep that in your notebook, and later we will be able to decide whether you have got the correct answer only based on resolution. That is, all of you might be getting different answers. It is okay. If you can use the representation that you have written in resolution, that means what you have written is correct. Even if you are getting different answers, your answer may be correct. You can conclude that a particular answer is wrong only when you feel that it cannot be used in resolution procedure. If it can be used during resolution, definitely what you have written is correct. So based on the idea that you are getting, you write WFF. Okay, we can see the answers later. Thank you.